me share my screen. So today we would be discussing what an entity relationship diagram is. I hope my screen is visible to you. Hello?
Zoom in the screen.
Yeah. Okay. So this is something, a previous recording that I had done for explaining what an entity relationship diagram is. So I'm not playing the recording as of now, but I'll explain you directly from here what it is, and this recording I'll share with you guys so that you can also understand what an entity relationship diagram is later on for your record and for your understanding. So basically, what we have is in a database. First of all, we need to understand a database is built over a schema. A schema is something on which we create a database, and we have different entities and different attributes of those entities which are linked to each other. So, like schemas, I'll come to a later stage what a schema is. But for right now, for your understanding, for of an entity relationship diagram, like in a database, we have tables. Every table has its columns. So a table is an entity, and the columns are known as attributes. So right now, this is a sample ER diagram that I have taken. So these are actor, film, inventory, rental, customer, store, address, city, film category. All these are the entities, and the columns that these entities have, these are called the attributes. The relationship between these entities form an ER diagram. As the name suggests, entity relationship diagram. So it explains the relationship between the various tables or entities. Tables are nothing, they are entities only, or entities are tables. They are one and the same thing. So if I say a table or entity, you must understand it's one and the same thing. There is no difference in them at all. So, like you see, the table actor and the table film actor. The table actor has different attributes like actor ID, first name, last update. And the film actor table has actor ID, film ID, and the last update. So, from these two tables, what all columns that I see are very much common between them. Actor ID over here, it mentions it as primary key. Over here in this corner, it is written as PK. This is a primary key for the actor table. In the film actor table, actor ID is the primary key and the foreign key. So foreign key, it would act as a foreign key for the film actor table, and the primary key for the film actor table. Foreign key, why? Because from the film actor table, I just have the actor ID and the film ID. But from where I would get to get the details of the actor, that would be from the actor table. So the actor ID acts as a foreign key in the film actor table for the actor table. Understand? Then we have film ID, last update, and everything. So from actor ID, I can get first name, and the last update for that particular actor for the particular film. Now this film ID. Now if I say these two tables only, let's say actor and the film actor. So there is a relationship that is denoted by this straight line, a small circle, a three extendable lines which are oozing out from that circle, and there is a straight line over here. What these lines mean actually. So an actor, just try to understand, an actor can have one or many films associated with him. You understand? This is a film actor that has a film ID in it. So this table has a lot of film IDs associated with it. So it mentions that a particular actor worked in certain film. So that film is denoted by a film ID. Now, an actor can work in one or many films, right? And a film actor, for a particular actor ID, there will be only one actor. It's kind of a roll number, it's kind of a phone number. So, an actor ID for a film actor will have only one actor associated with it. It cannot happen that an actor ID 10, there would be 10 actors over here. and actor ID 10 would represent only one actor. So when I say, when I have to, when I'm reading from this table, actor, film actor table to the actor table, so I read from this direction, from down to up. I'm reading from film actor to the actor table. This shows that for every actor ID in the film actor, there is only one, this represents one and only one. When I cut this line, it means one and only one. You understand? For every actor ID, there is only one and only one actor in the actor table. But for every actor ID in actor table, there could be one or more than one actor IDs. One or more than one film IDs. Or in other words, I can say that one actor can work in multiple films, but every actor has a single name, one and only one name, one and only one actor ID. This is how we interpret this symbol. This is how it defines a relationship between actor and the film actor table. Now, let's take another example. Let's take film actor and the film table. So, the film ID over here in this table, the film table, it is the primary key. Film ID over here is the primary key. Now, when I want to get the details of the film for a particular actor, I would reach out to the film table, right? I would reach out to the film table. So, for every actor, there would be one and only one film ID. एक एक्टर के corresponding there would be at least one and only one film ID. But for one film ID, there can be one or many actors, because in one film there are many actors that are working. So this symbol, when there are three lines going out, it represents one or many. So whenever there are three lines going out from a circle, it represents one or many. When there is a straight line and when it is cut with a straight line, it shows one and only one. So there are many relationships defined as, I'll just take a notepad. Where is my one note? Okay. So, So, in an entity relationship diagram, there are these kind of relationships that we have. First is one to many, second is many to one. Many to one, then we have one to one, then we have many to many. So, how these relationships work? So, one to many means, for let's say I have, let me give you an example of a student and a subject table. So a student would be studying many subjects, right? For one subject there can be many students. So from student to subject there is one to many relationship. One student can study many subjects. So from student table to a subject table or the course table, so a student table has one to many relationship towards the subject. A subject table has many to one a one to many relationship towards a student subject, because one subject can be read by many students, but one student can read many subjects. So it's a many to many relationship, one to many relationship between both the tables. I'll come again. I'll give you an example. Let me search an example for you guys. entity relationship diagram. Example, let's say. Yeah, let's take this one. So, right now these are different entities. I have apparel size, I have a product, I have product categories, I have different categories, I have product colors, I have a color table. All these tables are linked to each other by some or the other ID. Like the product table has product ID in it. This product ID can help me identify the color ID, it can help me identify the size, it can help me identify the category in which so this category table, this there is a product category. So category ID, I have a category ID over. I can get the details of what categories there are. This product table is connected to the product category. So the product ID and the category ID, these would act as a foreign key and a primary key relationship between the two tables. So for every product ID, let's say a product ID, let's say it's a shirt. So a shirt would have a product ID. This product ID will be linked to a category ID. So this represents the shirt ID. The product is shirt, but it falls in which category? It falls in a garments category. If a product is, let's say, a mouse, a laptop, it falls in what category? It falls in an electronics category. So for a product, for a product, there can be many categories because a shirt, a t-shirt, a pant, a jeans, a top, a sari, a kurti, all these products have a different product ID, but they fall under only one category, which is garments. Now, but for every garment category, we have different like top wear and bottom wear, those kind of categories. So for one product ID, there can be many categories. So for a shirt, I can have many categories based on the collar type. Let's say Chinese collar, Mandarin collar, or a French collar, or an English style collar shirt. So for one product, there can be one or many categories. This represents one. Whenever there is a dash, it represents one, and it can have many categories. Similarly, a product a product category and the categories table. So category ID, there can be only one and only one category ID. A garments, a jeans category, an electronics category. So in electronics category, it's a single category. There cannot be multiple electronics categories. So that's why it is represented by two arrows, no, sorry, two lines that show a category, a product ID category can have only one and only one category. And for a category ID, there is only one category, one product category. I guess I don't know whether I am able to explain it properly or not. Now we have product colors and we have colors. So color ID, and there are different colors where a color ID will have a color code and a color name. So let's say a color ID 10. So color ID 10 will represent only one or many colors under it, because you have pink, you have baby pink, you have dark pink, or you can have only just dark pink. So it can have one or many colors under one color ID. Black, yeah, there are different shades of black. Green, there are different shades of green. Or we can have, as per our requirement, let's say I have only sky pink, oh sorry, sky blue color. So there would be only one color ID for blue, will have only one color. Or it can have many colors as well under this color ID, under this color ID. So that's why it is represented by a straight line and multiple lines are coming out of it that represents one or many. This represents one, this represents many. You understand? But for one color ID, there is only one product color. So this color ID, there would be only one color ID, so therefore there is no arrow, nothing over here. We'll take another example. Let's say go with this one. So over here, I have a shopping basket book, I have a book, I have author table, I have a publisher table, I have a customer table, there's a shopping basket, there's a warehouse, there is a warehouse for books. So let's analyze what every table has. So a book table has an ISBN number that identifies the book separately. Every book has a single ISBN number. There would be a publisher name, author address, year of publishing, the title of the book, and the price of the book. Now, if I want to identify the author name, the address of the author, the website of the author, I would reach out to the author table. The author table has its name, address, and the URL. So the author name acts as a primary key over here, and over here I can identify the name of the author, address, and the URL of the author. For every author name, mind it, there would be one and only one author over here. But for every author, there can be one or many books. An author can write one. It can be represented by a dash or a circle. Both the notations are correct. Don't get confused on that front, because in the previous diagram I showed that there is a line over here, a straight line. Over here it's a circle. Both the representations are same. Some write in this way, some write with a dash over here. So an author can have one or many books written by him. So an author has one to many relationship with the books table, but a books table has only one and only one relationship with the author table, because one book can be written by only one author. There cannot be multiple authors for a book. If Sidney Sheldon has written a book, or Dan Brown has written a book, or Chetan Bhagat for example has written a book, he would have written one book under his name for that specific book. Uh, let's say 5 point someone written by Chetan Bhagat. So the ISBN number for that book is 1. That book is the one book that is written by that particular author. So for one book there is only one and only one author. But for one author there can be one or many books. An author can write a single book. Ved Vyas, he has written only one book, Mahabharata. But Chetan Bhagat has written many books. So for Chetan Bhagat it would be one and many books, but for Ved Vyasji it would be one and only one book. You understand? Now, but for a book, let's say Mahabharata, there is only one and only one author. For 5 point someone, there is only one and only one author. For, let's say, men are from Mars, women are from Venus, that's a book. I'm not joking, that's a book. So this book has only one and only one author. That's a relationship how one and one relationship and one to many works. Again, a publisher. For one book, there is only one publisher. Say Kalyani Publishing House, or some Gita Publishing House, or let's say Pearson Publishing House. So every book will have only one and only one publisher. But one publisher can have one book or can have many books under his name. So the relationship from publisher to book is one publisher to many books. But for one book, there is only one and one publisher associated with it. You get my point? Now, let's take this example, a warehouse and the book and the warehouse. So there's a warehouse code, there's a book ISBN number, there's a count. So warehouse code gives me information about which warehouse the book is coming from. The book ISBN number, this becomes the foreign key for this table. So the book ISBN number over here will act as a foreign key for this table. Over here ISBN is the primary key. This would be the foreign key. So for one book, there can be multiple or one warehouse. It can come from multiple places. It can come from one single place. That depends on the sourcing of the book. A book can come only from one specific place in London. Only one single book house, the London Library. But it can come from, if the book has other copies, it can come from India, it can come from China, it can come from warehouse in Japan, it can come from warehouse in US, anywhere. So for one book, there can be one or many warehouses, but for one warehouse code, there could be only one book. Because in one warehouse, if I check out one ISBN number, I would find only one and only one book of that category. The number would be more, I'm not saying, but that book would be one only. Like for that ISBN, it would be one ISBN only that would be available in this warehouse. So a warehouse code and a warehouse. For a warehouse code, there is only one warehouse. Just like a student with roll number 10 associated with XYZ International School. So that student would be associated with only that school only. So one warehouse code would represent to only one warehouse only. So code has one and only one relationship with warehouse. But a warehouse can have multiple warehouse book centers. Understand? Let's say Oven's warehouse company. So I can have multiple warehouses where multiple books come out. So that's how one and only, one to many relationships work in an ER diagram. Now, why it is important? The importance of ER diagram is that at times when you are dealing with multiple tables, over here it's like 1, 2, 3, 4, 5, 6, 7, 8 tables only. But in reality, you have hundreds and thousands of tables in a database. So, to remember what is the foreign key, what is the primary key, can I find my book, can I find my book details from publisher table, can I find my book details from a shopping basket, or can I find my customer details if I know the book details. So this ER diagrams helps us understand that we can find out details this way. Like now, if I want to find out which customer bought which ISBN book, that is possible because I know the ISBN number. From this ISBN number, I can connect to the shopping basket book table through this ISBN number. From this ISBN number in the shopping basket book, I can connect to the shopping basket ID through the ID. From this ID, I can get the email details of my customer. So I can find out for ISBN 1 or X or XYZ which customer bought that book. This is through this connection, this relationship between the tables. From book to shopping basket book, from shopping to shopping basket to the customer. So this entire relationship helps me understand how I can traverse, which tables I can link together, which tables I can join to reach out to my final result. That is why when the databases or the schemas are too big or too huge, then we need an ER diagram to understand how to traverse to the final result, how to get the final information. Let's say somebody says that I need to find out the publisher who published so and so book, and I want to know that that book is available in which warehouse. I just have the name of the publisher. That's it. From this publisher, I can find out the publisher name who purchased, who wrote which and which. By linking publisher table with the book table, I can find out on the basis of name. I can find out the name of the publisher, and then I can derive the ISBN number of that book. Now, if I want to check out that in which warehouse that book is available, I can connect this ISBN number to the warehouse table and find out the warehouse code. From this warehouse code, I can find out the warehouse location. I can get the phone and address of that warehouse. I can call that warehouse and say that I need the book by so and so publisher. Please source me this book. It is available in your warehouse. You understand? This is how you can say that this is a book management system, a bookkeeping database, a library database. So this is how you reach out to a final conclusion, the final thing, where you want to get the final details. So on ER diagrams, I'll give you a small understanding of how ER diagrams are made. Generally, you don't require to make an ER diagram. There are various tools that generate the ER diagram for you on their own. So now, a student is a table. There is a student table. These are the roll number, name, and birth are the attributes of the student table. Like what we have written over here. Let's say this is a student table. Let's say this is a student table. Name, address, and the student ID are the attributes of this table. So they have just bifurcated it in a broader way to make you understand what are attributes and what is an entity. So over here, attributes are the properties of the entities. Attributes are represented by means of ellipses. In this way, we represent the attributes. Every ellipse represents one attribute and is directly connected to the entity. Entity is represented by a rectangle. Don't go into the shapes as of now, those are not required. An entity relationship diagram works like this. You just need to understand that the name of a table is called an entity. The columns of that table are called the attributes, because generally people would ask you in an interview, there would be a question for sure asking you that, okay, what is the difference between an entity and an attribute? What is an entity and what is an attribute? You should know that entity is a table, attribute are the columns of that table that define that entity, that give meaning to that entity. So again, this comes to another debate, another question. What is the difference between a fact and a dimension? What is the difference between a fact and a dimension? Fact is something, let's say 30. 30 is a fact. Okay, 30 is a number. 30 could be an age. 30 could be a street number. 30 could be a pin code. It could be one of the digits in a phone number. It could be number of things. A fact without a dimension is of no use at all. You can give it any explanation for that number. But dimension is something that represents that fact. If I say age equal to 30, so 30 is a fact, age is the dimension that represents what 30 is, what 30 represents. So, in a similar way, ISBN number is just a fact. What is a dimension? Book is a dimension for that fact. So, book is a dimension. ISBN number, whatever number it would be, it is a fact. But ISBN represents it to be its dimension. A name, Avin, is just a name. If I say author, teacher, scientist, programmer, that is my dimension. If I say IT department, okay, it's just a name. But IT department has 30 people working in it. That gives a fact to that table. That gives fact to that dimension. Facts and dimension exist with each other only. So a name, any name is a fact, but representing that it is an author's name, that is a dimension to it. These are the questions that are generally asked in an interview. What is the difference? For every fresher, they would generally ask such kind of questions to get a in detail understanding that whether you people are clear about the concepts or not. They would ask you what's an entity and what is an attribute. They would ask you what is a fact and what is a dimension. They'll say 10. What does 10 mean to you? You can say anything. You would be, if you don't know a thing, what they want to ask you would be like 10 is just a number. No, you mention that thing, 10 is a fact. But if I get a meaning to this number, that would define it to be it's a dimension. Age equal to 10, it's a dimension. Count equal to 10, count of books to be 10, count of lollipops to be 10, count of toffees, count of chocolates equal to 10. So that's a dimension to it. Name, Rushmita. A name, it's just a name. Okay. Rushmita working for Agrosoft, working for Novartis. She's an employee in Novartis. She's a data analyst. She is 26 years old. So all these things, age, designation, name, uh, um, whatever you define, give name or give value to that fact is much more important for framing a database. You can't frame a database if I say, uh, I give you number 30, create a database out of it. No. If I say, create a table for students of age equal to 30, that gives you a dimension, that gives you a way how to go forward to create that table, how to get into that field to understand, okay, age is a fact, fine. I have people of age 30 years old. Now, what more I can get information about them? I should need to know their name, their address, their phone number. That would help me create a table for those set of people. In this way, a table is created. From facts and dimensions, a table is created. From these tables, a relationship between the tables is created, which helps us gather information in the way we want through the relationships between these tables, which form an entity relationship diagram or entity relationship pattern between the various tables that helps you understand how to reach out to the final solution that we want, the final ask of the client, the final requirement of the client. How do we reach to that point? So this is what an entity relationship diagram is all whole, all together, to understand which joins I have to apply to reach to this table. On what basis I can reach from books table, how I can reach to the customers table. Look on the screen. On from books table, how can I reach to the customers table? If I say find out rushmita.tandan at gmail.com bought a book, let's say 5 point someone, on which date, in which year did she buy that book? How would you get to know? How would you get to know? You need to understand that from customer I have to reach to my team's table, for to the books table. How would I reach to that table? This diagram helps you understand how to reach that table. And for every database, there is an entity relationship diagram. So, like in MySQL, I don't remember as of now how do we reach out to what is happening. This is my table. Huh? Hold on. Okay, let's say what nonsense. Okay, let's say I am onto my database, and over here, let's say reverse engineer. There's a way in MySQL where ER diagrams are generated. So over here, like there's an option to create an ER diagram. So yes, there are options to create ER diagrams as well. I have an ER diagram over here that I would like to show you. Let me just check it out where that ER diagram is for my this table. Okay, let me just try running this, and yeah, database, migration edit, no, reverse engineer, then continue. Okay, okay, this continue. Now it asks me to select the tables. Okay, continue. No, let's say I'll execute. So now continue, close. See, can you see this thing? So let me just enlarge it and move this nonsense thing in a bigger manner. See, I had a database. Don't bother about what database I use. This is something from my training days when I was learning SQL. So I had a database already created. So the tables were created on my own. Then I wanted to
So we
understand
didn't.
what. Yeah.
So we didn't use any formula here. Like we
No.
just normally went, which is already
Yeah.
installed, installed in SQL.
Yes. Yes. There is no
Yeah.
formula to
So
create.
we just given the data to it, and we asked to make it a diagram for that.
Yes. Yes.
Right.
So I don't remember. I don't know whether SQL Server has this kind of option to create an entity relationship diagram or not. But generally, let me tell you certain things. I'll just take 10 more minutes of the time because I'm also just a minute. So Okay. Is the password? Yeah. So yeah, over here, toolkit. When I go with SQL, join SQL study advanced SQL. This is the start. This is the database that I just showed you over here. This is the ER diagram for that database. What I designed on that front while I was giving my exams and everything. Now, what I wanted to show was no, not this one. Yeah. So generally, in an interview, this has happened with me. What they'll do is they'll give you an ER diagram. They'll give you this ER diagram. You have this ER diagram with you. This is what I started training you on which I have created a video. I'll share that video with you guys after this session. So now, on basis of this ER diagram, you have questions. So write a query to find the full name of actor who has acted in maximum number of movies. So actor and movies, that's a question. So now this is the actors table. This is the film table from where I can get the information. But how? I need to understand what is the primary key, what is the foreign key. So on that basis, I can write a query just by seeing this ER diagram. We'll get on, that's a high level thing, how to write a query on certain things. I'll make you practice on these questions. So I had put a join over here. I put a join on actors table. So if you can see this from actors table, I have put a join on the film actors table to get the full name. Fine. And got the result out of it. So full name, I what the output says is I require the full name and the name of the movie, the maximum number of movies the actor has acted in. So the actor table and the film actor table. That basis, I can keep a count of the film ID. I'll explain you. Forget it what I'm telling you as of now. The question says the question says write a query to find the full name of the actor who acted in the maximum number of movies. So the question is I need the name of the actor, the first name and the last name combined together. If there are two columns, let's say first name and last name, I want Avin in first name, last name is Seth. I want the full name. Avin Seth is the full name. I want Avin Seth and the maximum number of movies that I have done in my career. So over here, uh, leave it over here. So this is in this table. I have first name, I have last name. My first priority is to get the full name. So what I'll do is, just like in Excel, we have concat function. Over here also we have a concat function. I concatenated first name space last name because I can't have Avan Seth going. I'll have Avan Seth. I denote it as full name. As is something, I write it down as something, I need the name of the column. So this will give me the name of the column. From which table? I am talking about the actors table. I am putting an inner join on the film actor table. So first name and last name I am gathering from the actor table. I am putting an inner join from the film actor table on actor ID because this is a primary key over here. This is a foreign key over here. So see, I put an inner join on the film actor table using actor ID, or I can put it this way also over here on A dot actor ID is equal to FA dot actor ID. See, just understand this thing, what I have written over here using this using part, guys, just listen carefully. This using part, it is equivalent to what I have written over here. Only point is, make it a habit to write in this way: a dot actor id equal to fa dot actor id. Don't write this way because most of the SQL interpreters doesn't understand the using keyword. Don't understand the using keyword at all. So once I do this, my tables are joined. What I need to know is the count of the movies. So I'm putting count of the film ID in descending order. I grouped it on the basis of, I'll let you know how these things are working, but from this thing, it is quite clear that how I can link, how I can get my final information when it asks need the full name of the actor. So I reach out to the actor table, check out whether the first name, last name is present over there. I join them and get the full name. Now they want the film ID or the film name or the maximum count of the movies that I have done. So for that, for the matter of fact, let's say in a table, in this film actors table, I have Avinsate film ID 1, Avinsate film ID 2, Avinsate film ID 3, Avinsate film ID 4. I'll show you. Just a minute. Give me a minute, guys. Yet you guys are understanding what I'm saying, right? Because I'm not. It shouldn't happen that it's just a one-way communication. Just let me know that you guys are understanding this thing, otherwise there's no point of having this conversation what we are doing right now. Let's say first name, let's say first name, last name, Avan Seth. Now I have another table which is the which was what it was. It was actor film actor table. So it has actor ID, it has film ID. Let's say it has only two columns, and this table has another column which says actor ID. Fine, let's say actor ID 1. So actor ID 1, film ID 1, actor ID 2, film ID 10, actor ID 3, film ID 4. Sorry, actor ID 1, actor ID 1, actor ID 1, film ID 5, actor ID 2, film ID, let's say 6, actor ID 3, let's say film ID again 1. Now what they want is, let's say film actor Rashmita, let's say Abhi, let's say 4 Ganesh, say 5 Uday, 6 Madhu. Fine. So over here what they want is the requirement. So the requirement is I need the full name of the actor with the maximum number of films. Over here, if you see this table, actor ID 1 has done 4 films. So the count for films for actor 1 is 4. So the number of films done by actor 1 is 4, number of films done by actor 2 is 1, number of films done by actor 3 is 1. What they need is the final result should be full name as Avinsate, Rushmita, Abhi, and count of film ID. So for Avinsate the count of film ID is 4. For Rushmita, the count of film ID is 1. For Abhi, the count of film ID is 1. How we are doing this thing? First of all, we'll join these two. So, concat, sorry, concat this space this. I get this. So firstly what I did was select concat first name comma, I give a space, then I enter last name as first name. So this thing basically over here, this is the actual thing. What I am doing is, if I don't give it a name to it, like first name, like I have given over here the first name, the column name that would come up in the final result would be concat first name space last name. This would be the name of the column, but I need the name of the column as first name, so I have entered it as first name over here. Fine. So when I'm doing this, so after this value is taken from which table? The actors table. From actors, I give it an alias as A. Now I put an inner join to it with actor ID, with like film actor table, film underscore actor table, and give it an alias as FA. On which column I would join? On A dot actor ID is equal to FA dot actor ID. Fine. If I run only this much, it will just concat first name and last name and give me the final result as full name. But I want to have the count of movies as well. Fine. So what I will do is I'll group. Over here, if I say the count, it will say 1 1 count, 1 1 count, 1 1 count. It will give me like this. But I want all these to be combined together. So what I'll do is I'll group. I'll put a grouping condition. I'll group on the basis of actor ID. I'll group on the basis of actor ID. So what it will do is it will pull out all these actor IDs into one. It will take it as 1, 2 as 2, 3 as 3, 4 as 4, and over here, once I am putting a group by condition, I'll put a count. I need a count out of it. Just like over here, it says group by full name, order by count of film ID. So I am taking a count of film ID. So order by count of film ID. Limit is leave limit as of now, because in that point actually the question says I need the maximum. So in that kind of in maximum statement I'll let you know how it is done. So in this way this entire query would give me the final result of what we desire. This is possible only on the basis of just looking at this ER diagram, only the ER diagram. So at times an interview, in most of the interviews happen offline. You don't have a face-to-face interview these days. So they'll give you a question paper, they'll send you an ER diagram and ask you a query. You have to figure it out, what is my path, from where I can get the information. We'll complete this entire set of these questions as well. I have other things also to tell you, how group by works, what is count function doing, how does order by works, what is the having statement, what having statement does. So we'll discuss this in tomorrow's class. Meantime, I want you guys to practice because understand what an ER diagram is. I'll share you the study material. You just understand what an ER diagram is, what are the various relationship between the ER diagrams, and I want 2 questions each from each one of you as doubts or as a learning what you got from the ER diagram tomorrow. In first 15 minutes we'll be discussing ER diagram, and I want each of your take 2 lines on what you understood from ER diagram, or what are your queries from the ER diagram section that we discussed today. So You have any questions? I'm open to any questions. Please let me know.
Shall
Otherwise,
we have 2 hour session on Sunday?
on not on Sunday. I'll be having 2 hour session on Saturday. I can extend it to 3 hours as well. But tomorrow,
Sat.
as if we are taking an off, I'll take a class on Sunday. I'll take a 2 hours class on Sunday. No worries.
Chalo. Done.
Tomorrow, okay. So tomorrow is an off for you guys. Enjoy the match. Yeah, Rushmita, you had any question? Please go ahead.
No, sir. I have to practice. If any doubts, I'll just let you know.
Please see, the only thing that you guys, that it will help you excel in this would be practice only. That is the only thing. Also, the time is running out, the session will close down soon, so I'll take your leave. You study this thing, please. We'll meet day after tomorrow. It will be a 2 hour class. Let's say we'll fix a time tomorrow. I'll take your convenient time.
Hmm.
It will be mostly 3 or 4 p.m., or we can take it IST, 3 p.m., 4 p.m., but I'll take a 2 hours class for you guys. I'll have a lot of things to explain, lot of functions to discuss, lot of things to work out on coding part. We'll cover it on Sunday, and probably by Tuesday your sequel part would be complete, and then we'll move on how to attempt various questions, how to attempt complex queries and everything. Sounds good?
Yeah. So one last question. Like after the sequel, we step into Python and then Power BI, right?
Power BI, I'm not good at Power BI yet. So I'll be teaching you Python for sure, but not Power BI.
Okay, that's fine.